In this video, we will go over the limit comparison test. And with the limit comparison test, we have one series that we don't know what will happen, but the other series we do. And so if you have the limit of n approaches infinity, a sub n divided by b sub n, if it is equal to L, where L is a finite positive number, then both series will either converge or diverge. And it will be based off of the known series. And so overall, the limit comparison is helpful when the direct comparison doesn't work. This is just an extra note. If L is equal to 0 and b sub n converges, then a sub n will also converge. And you can kind of think, if a sub n divided by b sub n, if b sub n grows faster than a sub n, this will cause the limit to be 0. And so if b sub n converges, then a sub n would also have to. And I guess you can think of another way. If a sub n divided by b sub n, if that is equal to 0, this means that a sub n is so much smaller than b sub n. And if b sub n converges, then a sub n would have to also. Likewise, if L is equal to infinity and b sub n diverges, then a sub n would also have to diverge. And you can similarly think, a sub n divided by b sub n. If b sub n grows slower than a sub n, this will cause the limit to be infinity. So if b sub n diverges, then a sub n would have to also. And another way you can think about it, a sub n divided by b sub n. If that is equal to infinity, this means that a sub n is so much bigger than b sub n. And if b sub n diverges, then a sub n would have to also. So this is the problem that we will solve. Do the following series converge or diverge? And we only want to use the limit comparison test. And so if you want, you can pause the video here and attempt this problem. So first, I will make my comparison. And this is the comparison I will make, 1 over n squared. So we can say that a sub n is equal to this series and b sub n is equal to this series. So now we do the limit of n is approaching infinity, 1 over n squared plus 3, this term right here, divided by 1 over n squared. And this will equal limit of n approaching infinity of n squared divided by n squared plus 3. This n squared is going to the top. Next, we can divide each term by n squared. So divide this by n squared, divide this by n squared, and divide this by n squared. And we get this. This would mean that n squared divided by n squared is 1. N squared divided by n squared is 1. 3 divided by n squared is this, and is equal to 1 because, n is approaching infinity. This becomes 0. So 1 divided by 1 is 1. So therefore, both series will either converge or diverge using the limit comparison test. And we need to determine what will happen. So we know 1 over n squared. This series right here will converge by p series because p is equal to 2, which is greater than 1. So therefore, the series that we want to solve for will converge by the limit comparison test. And that's all we need to do for this type of problem.